And we're good on Zoom. All right. Well, I will go ahead and get us started here. So, all right, everyone, thanks for attending today. So today we're going to be talking about Introduction to Phobos 2.0. And, if you've been on our mailing list for Pettibridge for a number of years, you've probably heard about Phobos 1 along the way. But in case you're totally new to Phobos and have no idea how it works, we're going to cover that too. We're also going to cover some OpenTelemetry concepts. Now, if you have any questions about anything that I'm presenting or anything about Phobos whatsoever, you can go ahead and use the Ask a Question feature inside Zoom. I will see a notification about it, and I'll probably get to those questions at the very end of today's presentation. So first thing I want to talk about is, what is Phobos exactly? Why would you want to use it? How does it work with Akka.net? And what are some of the features and benefits? Next, we'll talk about OpenTelemetry, which of all the concepts we're going to learn today, OpenTelemetry is the really big, important one you need to walk away with. Phobos is a instrumentation of OpenTelemetry for Akka.net, but OpenTelemetry itself is a much larger concept that, as I put it in our blog post about when we announced Phobos 2 a couple of weeks ago, you will 100% guaranteed need to know how OpenTelemetry works in the next couple of years. It's going to be inevitable. Then we'll talk about installing Phobos into Akka.net. How does that work? If you haven't seen Akka.hosting before, we're going to talk a bit about that today. You can install Phobos without Akka hosting, since Akka.hosting is pretty new, but that is a best practice. You do want to go ahead and start using it. It's going to eliminate a ton of boilerplate code from your application when you do. And that's what we'll wrap up with today also, are some best practices for working with both Phobos as well as working with OpenTelemetry. So what Phobos is, in essence, is it's designed to be a zero-code way of instrumenting your Akka.net applications to record metrics and to record distributed traces, meaning traces that can connect all of the behavior of your different Akka.net services spanning the network. So it requires a minimal amount of code to configure. With Akka.hosting, I believe it takes a single line of code to instrument Phobos, so it's very small. Phobos is built on top of OpenTelemetry, which we're going to spend a bit of time talking about in the second section here. OpenTelemetry is an open standard that all of the major APM vendors agreed upon. So that includes companies like Datadog, Microsoft, Google, Amazon, New Relic, Elastic, you name it. And they all agreed on how to define standard ways of instrumenting concepts such as traces, different types of metrics, exporters, logs. And these are all meant to sort of make it easy for library and framework authors like yours truly to expose metrics in a way that can be consumed regardless of what your preferred APM vendor is. And we'll talk about OpenTelemetry in a little bit of detail in a moment. Phobos also is able to trace activity over the network, but because of OpenTelemetry, we can also trace activity between Akka.net and non-Akka.net parts of your system. So for instance, the demo I'm going to use today uses ASP.NET Razor pages and Akka.net in tandem. And we'll be able to follow an end-to-end trace, starting with the HTTP request all the way through querying an Akka.NET cluster sharding system and getting some results back and running them on page. So that's what Phobos is designed to do. It's meant to be a very easy and efficient way to go and get visibility to how your Akka.NET applications perform at runtime. And yes, this will save you hundreds of hours of debugging and setup time. So a personal story from the past few weeks here, I created a repository that's public on Pettibridge's GitHub organization called Large Scale Network Tests. And we were spinning up basically between 150 and 300 node Akka.NET clusters. And we were running Akka.NET cluster sharding inside of there. And I found a pretty severe bug with the DData shard coordinator on there that no one had ever reported before. And it was Phobos that actually allowed me to figure out what was happening, because it showed me exactly where basically in the time frame this error started. And it started when the coordinator failed over for cluster sharding, and was able to show me this tremendous surge in network traffic of all these nodes trying to essentially reacquire the new shard coordinator home and trying to essentially reestablish where everything was in the cluster at any given time. And due to a bug with the way that actor is programmed, the system was basically never able to recover from that. And trying to troubleshoot that issue manually would have taken me hundreds of hours versus the 5 minutes that it took with Phobos. So Phobos really will pay for itself pretty quickly. It's a proprietary library. It does cost money, but it's fairly inexpensive compared to the value that you will get out of it. So the brand new features in Phobos 2, for those of you who've used Phobos 1.0, 1.x before, is that we migrated from app metrics and open tracing to OpenTelemetry. And the reason for that is that OpenTelemetry is the future standard that all of Microsoft's own frameworks are going to target for telemetry going forward. So ASP.NET Entity Framework, the HTTP client, probably other libraries too, like maybe Stack Exchange.Redis, all have support for OpenTelemetry. That's going to be the way you measure how your applications work going forward. So that was the really big change in Phobos 2. We also were able to use Akka hosting to simplify our configuration even more, although we did port that back to Phobos 1.x as well. We also significantly improved the way our APM is short for application performance monitoring. We're able to significantly improve the way we reduce the number of traces that are created by Phobos when Akka.net's really busy. We found some new ways of doing that are a lot easier than what we had before. And these will help make it easier to use the data produced by Phobos, and it will help reduce your costs on platforms like Datadog. Finally, the other thing we really improved with Phobos 2 is we changed the way we do end-to-end latency tracking. Before, when we would track how long it took to process a message, we were doing just that. We would start keeping track of the time when the actor began processing it. And then by the time the actor's receive method exits, we'd go ahead and just record, duration there and save it. Well, what we do now is we actually changed our format a little bit, so we can actually begin tracing an actor's basically a message's lifespan beginning from when it is first sent. So the very first actorref.tel will go ahead and record a timestamp, and we preserve that even going over the network, and we'll record how long it took this message end to end to get processed. And so this allows you to go ahead and visualize how much time did this message spend in a mailbox before it got processed, or how much time did it spend in flight getting transmitted over Akka.remote? What was the latency on that? And we have some new dashboards and everything we built around this that are designed to make it really easy to visualize what that latency might look like in a running app. So the way Phobos 2 works is we install the Phobos.hosting NuGet package. This NuGet package pulls in all of the other Phobos NuGet packages, as well as some of the OpenTelemetry packages that you need. You still need to define an OpenTelemetry metrics and tracing exporter. We'll talk about how to actually do that in a minute. But when this gets installed into your application, it'll take the meter and the activity source that are built inside Phobos and begin exporting both of those values out to the OpenTelemetry pipeline. You subscribe to it just like how you would the ASP.NET or HTTP client or entity framework metrics and traces. It uses an identical methodology to that. The one difference, though, is where do the traces and metrics from Phobos actually come from? Where is that data being produced? And the answer is that behind the scenes, what Phobos is doing, your actor is really constructed of a few different parts when you're programming Akka.NET actors. Most of the time, what you're looking at is strictly just the actor class, which is where all the message processing rules are. And that's really where your business logic lives. Behind the scenes, some of the infrastructure that Akka.NET provides include the actor cell, which is what your actor references really point to. The actor cell is the tissue that connects the actor that you programmed to the mailbox where its messages are stored, to the dispatcher that schedules the actor for execution. So the actor cell is not something you interact with directly very often as an Akka.NET user. In Phobos, we actually replace the actor cell implementation with a new one that has some of this instrumentation built into it. That's how we're able to transparently capture all of this data without you having to write instrumentation code yourself, is because we're doing it via this component that is active every single time you process a message, active every single time an actor starts or stops, and active every time it crashes. So that's how we're able to go and capture all the information. And installing Phobos into Akka.NET just involves essentially enabling the Phobos actor reference provider. That's the factory. It's responsible for spinning up actors. Whenever you turn on Akka.remote or Akka.cluster, you have to change your actor reference provider implementation. Phobos is the same deal. It wraps around the built-in Akka.NET ones and it is able to inject instrumentation into each of your actors through there. And so when activity is happening inside Akka.net, such as an actor sending a message or receiving a message, or an actor using an ask operation, or an actor crashing, or etc. These pieces of Phobos instrumentation automatically record traces and metrics, which then get exported via the OpenTelemetry pipelines that we're going to configure. So that's really what it is behind the scenes. It's a fairly simple concept. It has a lot of nuance in terms of how it's built, and particularly around trying to make it as performant as possible. For example, using Phobos metrics is actually zero allocation by default. There's no, we don't actually use any memory at all for that. We're able to get away with using value types and using just the stack basically to go ahead and do metrics. For tracing, we can't make it quite that efficient because it involves stringifying different objects and exporting them out as these somewhat verbose data payloads. And you can't really get away from having some allocations as a result of that. But we do work really hard to try to make this library as unobtrusive as possible. And we spend a lot of time developing and debugging it in order to make it convenient for Akka.net users to observe how their applications work dynamically at runtime. This is what a Phobos histogram might look like in the tracing system. And you'll see a live example of this in just a moment. But in this case, we begin with this HTTP GET operation that goes from, let's say, a web browser into an ASP.NET app. That's going to record one activity or one span, depending on which term you want to use. And that might result in us sending an ask operation to an actor. And my class is the message type here. And then down below here, we actually have an actor processing the message that was sent via the ask. And then this actor might run an entity framework query internally. And then when this entity framework query completes, this span will complete, this ask will complete, then the HTTP operation will complete, which is why you see the sort of these delimiters here, the size of the box might show you how long it took this operation to finish from start to end. And you'll see that these kind of shrink down as we get closer to it. And this is an example of what one of these actual actor interactions will look like inside Jaeger. Jaeger is an open source tracing platform that supports OpenTelemetry. There's a number of them that do. Zipkin and Jaeger are probably the two big open source ones that support OpenTelemetry tracing. There's also platforms like InfluxDB and Prometheus that support OpenTelemetry metrics that are open source as well. And we also have some ready-made dashboards. I'm going to probably demo one of these if we have time, but this is what our Phobos 2.0 dashboards look like. So on the left here, I can keep track of the number of exceptions by type, the number of errors that are logged, the total actor throughput. I've kind of condensed these down in order to fit them on one slide. But we also have further up here a graph that shows the entire distribution of the cluster. So how many nodes are there, how many are reachable, what role types are they, what status are they, et cetera. So you can kind of get a really good view of what your entire cluster looks like through Phobos as well. And then on the right, this is what our latency distribution charts look like in Phobos 2, where I can go ahead and see that for this actor processing a message of type int, most of my messages are processed in under 1 millisecond, with a small fraction of them taking between 0 to 5 milliseconds, so a slightly larger value. And you can go ahead and see kind of the long tail of all the different latency distributions here. This is using what's called a histogram type in OpenTelemetry to keep track of that. So now let's go ahead and talk a bit about OpenTelemetry. How do Phobos 2 and OpenTelemetry work together? Well, before OpenTelemetry, in terms of what the state of the APM ecosystem looked like, every vendor did their own thing. They all had separate clients, separate SDKs, separate agents. And essentially, if you wanted to move between New Relic and Datadog, that might actually be a pretty significant project. But the gist of it is that if you go ahead and want to expose metrics in a consistent way to all these different vendors, what you essentially had to do if you're a library author was you needed to go ahead and expose event hooks that would allow the end user to connect their own APM code to it. And it involved essentially a lot of work for both the library author and the end users of it to integrate, to essentially perform the same boilerplate work over and over again for every APM vendor. On top of that, migrating between vendors meant rewriting all of that each time you did it if you were an end user. So this was pretty nasty. And this has been what the state of the ecosystem has been like for most of its history. Now, there were some projects like app.metrics, which Phobos 1.0 used, that tried to build wrappers around these SDKs to form a common grammar. So the idea behind this was, okay, well, Datadog, Elastic, and New Relic all have a concept of a counter, and they might vary slightly, but we're going to go ahead and try to make sure that we have a common language we can use to instrument those. And this was an improvement, but it was still a lot of work. And probably the biggest downside of a tool like AppMetrics was that every single APM vendor would basically have their own idiosyncratic way of doing everything. And you couldn't really come up with a common grammar that fit all these different clients very easily. Plus, every time they did a major SDK upgrade, it meant rewriting a significant component inside here. And then finally, the last phase of this before OpenTelemetry was we started to see some standards emerge for APM. Namely, we had the Open Tracing standard and the Open Census standard. So these were both, Open Census was developed by current Google employees. Open Tracing was developed by former Google employees. And they had somewhat different attitudes on how to go about implementing APM inside their systems. Eventually, what ended up occurring, we talked about this. What eventually ended up occurring was Open Census and Open Tracing merged into OpenTelemetry. And Open Census brought with it the ability to support common grammars for metrics as well. So now that OpenTelemetry is in the picture, it's much easier for library authors to expose their metrics and tracing capabilities in a way that is vendor agnostic, meaning I don't need to necessarily care about the little quirks and differences between Datadog and Elastic. That is now Datadog and Elastic's problem. If they want to cut off their nose to spite their face and not support a giant, let's say initiative like OpenTelemetry, then they're going to relegate themselves to a much smaller portion of the addressable market than they would otherwise. So there's a very powerful market incentive for those vendors to get behind the OpenTelemetry movement. Let's see. I see we have a couple of chat questions here. Let's see. Does trace also work on the send operation in Akka.net? Yes, it does. It does work on the send operation. And it's basically, we go ahead and we propagate trace from an existing external context, and we package it into a little envelope that the actor can process. That's how we're able to connect the dots between something like ASP.NET and Akka.net, or between other Akka.NET actors. Yeah, Mariano's right. I should go ahead and wait until the very end to answer questions. Okay. So what makes OpenTelemetry different? Well, the biggest thing is that all of your metrics and traces are actually produced using the OpenTelemetry library, meaning that all of the core metric and trace concepts are implemented in a standard library that I target. That means that my performance in terms of how expensive it is for me to produce a trace is going to be the same, regardless of whether I'm using Datadog or Jaeger or Zipkin. Doesn't really matter because the library is what produces that data. Whereas before, with something like Open Tracing, all these library vendors had to implement an interface, but those implementations could vary wildly in terms of performance. And we saw this quite a bit with Phobos 1.0, that I would go ahead and write some stuff against the Jaeger library, and someone would drop in, let's say, a Datadog library, and the performance characteristics couldn't be more different between the two of them. So that problem has been solved. I now have this sort of consistent performance that I didn't have before. Everything is vendor neutral. We use an export pipeline to go ahead and connect to all these different APM vendors. And then finally, this is safe for me to go ahead and embed directly into, let's say, libraries if I really wanted to, because OpenTelemetry, if nothing is connected to it, then it doesn't produce any data. So I'm not going to end up creating additional allocations by accident if I don't want to. Now, the last thing that's really useful to me as let's say, someone who writes tracing and metrics instrumentation for a living is that now I finally really do have that goal that app.metrics set out to achieve, which is a consistent grammar for different metric and trace types across all these different companies that our customers want to use for APM. So it's the vendor's job to go ahead and support things consistently. I've been working with a customer that's trying to use Datadog, for instance, and their support for supporting OpenTelemetry metrics is still a little half-baked, in my opinion. Well, that's their problem, not mine anymore. Whereas with app.metrics, it used to be my problem. So this is kind of a nice paradigm shift that's going to reduce both my total cost of ownership and your total cost of ownership as an end user. It puts a lot of the work to consistently support these things onto the companies that are selling you their APM instrumentation, rather than the people writing the code that produces the data. And so this is what the OpenTelemetry sort of processing pipeline looks like. This part I'm about to describe is actually totally unique to .NET, in my opinion. This is leveraging some existing infrastructure that's been available in system.diagnostics.activity for a long time. The way tracing and metrics are both implemented is using what's called a sort of an event pipe, which is a low-level type that you don't directly interact with in system.diagnostics. And each time we go ahead and record an activity, this is going to produce an event on this event pipe that'll sit there in a buffer for a limited period of time. And if that event pipe's not connected to anything, then the event will just get no-opt and we'll basically won't allocate anything. However, if there's a subscriber to this event pipe, then each time this activity source is invoked to produce a new activity, we will create a new activity object into that event pipe, and we will update what's called the current activity. There's a little async local variable that keeps track of what the current operation is when you're doing traces. And that will go ahead and allow me to pass that context of that currently active operation into any child operations I create inside the same async local context. So if you imagine a call chain where you have an HTTP request come in, your controller handles it, then it awaits on a database query, then maybe it awaits on an Akka.NET ask operation, and then finally it awaits on maybe serialization at the very end. Well, each one of those awaits would basically be one activity in the context of OpenTelemetry. Now, it doesn't necessarily have to be that way, but that's sort of what the convention is meant to be in this sense. So in the case of Akka.NET, every time you send a message to an actor, that's going to produce a new activity that's going to show up inside your export pipeline. Whoops, down at the very end down here. So this tracer provider is something you configure in your startup class or in your, if you're doing .NET 6, your minimal configuration. You go and configure this via a little Fluent Builder class that we're going to see in a moment. And you go and connect it to one or more processors if you want. Processors are useful for doing things like sampling. So if you have a really busy system and you want to reduce the amount of data that you're sending out to a platform like Datadog, because you get billed based on the number of events or the number of dimensions, you can use a processor to filter that after the data is being produced. Most instrumentation libraries like Phobos and the ASP.NET one actually have filtering that prevents traces from being sent to the trace provider in the first place, which is an even more efficient way of trying to reduce the overhead of your APM solution. It's because it basically stops allocations, and on top of that, never gets into the processing pipeline to begin with. And then finally, we have one or more exporters at the end. These exporters will actually take your traces, and we'll see the metrics pipeline in a second, and delivers them usually over the network to some sort of agent that's going to process them for you. So we're going to look at Jaeger today, which is a standalone open source agent. However, I've also done this with Datadog, and we've had customers do it with platforms like Elastic and Application Insights already. So OpenTelemetry already has, even though it's still fairly early into the market here, still has fairly broad adoption and support across most of the major platforms. OpenTelemetry metrics work essentially the same way. The one difference being is that, well, two differences. One is that you use meters to go ahead and record metrics instead of activity sources. And on top of that, metrics are uncorrelated, meaning that a metric produced by ASP.NET Core has no relationship to a metric produced in Akka.NET directly. It's not like tracing where there's a context that has to be connected together. Metrics occur somewhat independently from each other. So what will happen in this instance is each time I record a value using my meter, I will go ahead, and meters basically expose different metric types under the covers, counters, gauges, histograms, that sort of thing. Every single time I produce a number of updates to, let's say, a counter, those will be aggregated in the meter provider, and they'll usually be summed together in order to debounce some of those events. So if I go and update a counter 100,000 times a second, which by the way is not unthinkable, that happens pretty frequently. I've even seen millions of messages per second before on an OpenTelemetry counter. What the meter provider will do is it'll essentially debounce those events. So rather than pushing a million counter increment events over the wire, it might compress them into, let's say, a handful of counter events that represent 100,000 increments each. And that's something that we can do pretty efficiently in memory here using the OpenTelemetry infrastructure. That's all happening for you automatically behind the scenes, by the way. Let's talk a bit about OpenTelemetry and .NET. As of .NET 6, OpenTelemetry is the official solution for all Microsoft frameworks. OpenTelemetry was not released out of RC until about a month ago. As of version, I think it's 1.2 is now out of release candidate status. But it is going to be the official solution, and you're going to see a lot more of it in .NET 7 when that comes out in the fall this year. I think it's supposed to be November. So you're going to need to learn it. It's inevitable. The good news is that OpenTelemetry is backwards compatible all the way back to .NET Standard 2.0. So you don't need to be running on the latest version of .NET to use it. You can still use this inside. We've got one customer running it inside .NET Framework 4.61, which is the oldest version of .NET that supports .NET Standard 2. This is also, incidentally, what Phobos and what Akka.NET support today. Akka.NET 1.5 will support dual targeting for .NET Standard 2.0 and .NET 6, but that's neither here nor there. Phobos will still be compatible for all that stuff. The packages that you need to install in order to use OpenTelemetry are the system.diagnostics.activity and system.diagnostics.metrics packages. Now, if you install the OpenTelemetry.api NuGet package, that's actually going to bring both of these dependencies in for you. And that's what we use inside Phobos. So we kind of take care of some of that for you there. Now, these libraries are also designed to be very high performance. They're being used in platforms like Bing, for instance. So OpenTelemetry is getting very heavily battle tested in .NET. It's not some new experimental technology in the same way that Blazor might be, for instance. This is from day one getting used at some very high levels inside Microsoft. And it's also getting used at very high levels by our own users too, I might add. Now, in terms of some of the key concepts and terms from OpenTelemetry and .NET, the biggest ones are for traces, these ones, the activity source / tracer. So on the left, these are the system.diagnostics.activity names for these constructs here. That's kind of a legacy thing that Microsoft had. And in order for them to take a dependency on OpenTelemetry inside any of the base class libraries, Microsoft really felt they needed to control the surface of that API. And that's what these really represent here. On the right, we have the OpenTelemetry versions of these APIs. These on the right are wrappers around the APIs on the left, really. So we have tracer, telemetry span, and span context. The tracer is basically the activity source that produces spans inside your application. So Phobos has one of these built into it. Next, we have the telemetry span itself, a activity / telemetry span. I mentioned earlier, one await operation is pretty analogous to like what one activity should be. So every single logical unit of work gets its own activity, and a distributed trace in a platform like Application Insights or Jaeger is going to essentially be a chain of all these operations that are sequenced together. And then finally, we have what's called the activity and span context. This is a property of an activity. And when you propagate, let's say, a trace over the network, good example, when the HTTP client is involved in an active trace, let's say there's an active span right now, and it makes a request out to ASP.NET, it'll automatically use the W3C header for tracing to encode this activity context in that W3C format and send it over the wire. ASP.NET will automatically decode that context and create a new child span that references that previous one as its parent. So these sort of spans follow parent-child relationships. Akka.NET and Phobos will do the same thing for you. Phobos will automatically propagate activity context even over the network in Akka.remote. There are some examples in the OpenTelemetry.NET repository of how to manually extract and inject context. A good example of where you might need to do that is if you're working with RabbitMQ or Kafka, for instance. You would probably need to go ahead and access the active span, and then you would need to go ahead and extract that context into, let's say, a Kafka header or maybe a RabbitMQ metadata label. And you'd have to serialize that, package it over the network, deserialize it on the other side of the network, and inject it into a new span on the other side. So that's the manual correlation there. Phobos tries to do this automatically for you inside Akka.net as best it can. Next, spans can also include attributes, which are the searchable properties of a span. You'll see some examples of that Phobos includes automatically. Good examples, the actor type that produced this trace. That's the type of attribute that we record. So if you have a foo actor and you want to search for all errors thrown by foo actor, you can go ahead and do a search for all operation names. And you'd say, I want to set my actor type equal to this. And I want to set my error flag to on, and that would fetch all of these spans, all the traces that have a span that meets that criteria. And then finally, we have events. So every time you call, for instance, the Akka.net iLogging adapter, Phobos will record that log into your span as an event. And you can go ahead and see different events occurring in the course of processing one logical operation there. Another example of where we use events inside Phobos is when we start sending a message via Akka.net, when we call actorref.tell, that creates a event. And that event ends once the actor starts processing that message inside your mailbox. That way you can go ahead and look on your graph and see it took 6 milliseconds total to process that message. 5.98 of those milliseconds were that message sitting in my actor's mailbox. And the other 0.02 were my actor actually processing that message. That would be able to tell you that maybe your actor is suffering from back pressure to some extent, or maybe that the dispatcher is too heavily loaded. And these might help give you some useful performance optimization hints inside your system. For metrics, the concepts are a little simpler. There's no dual kind of API here because everything is just built on top of that system.diagnostics.metrics. So you have a meter, which is your activity source equivalent, but for metrics, this gives you the ability to create counters, observable gauges, and histograms. So counters are used for measuring rates and frequencies. They're probably going to be the most common type of metric you use. They support very simple increment events for the most part. And those typically get used by APM providers to compute rates and frequencies. Next, we have observable gauges. These are gauges that run asynchronously on a timer to measure arbitrary values over time. So for instance, we use them in Phobos to measure the total number of reachable and unreachable nodes in the cluster. That's one example of an observable gauge. One of my other applications, I would use an observable gauge to keep track of the size of the .NET thread pool at any given point in time. That way I could go ahead and plot how the thread pool was increasing and decreasing threads to correlate with workload in that system. So those are examples of things that work pretty well with observable gauges. Unfortunately, in Phobos 1.0, we used gauges to measure the depth of an actor's mailbox, and that worked great. Because OpenTelemetry doesn't support synchronous gauges right now, this is cost prohibitive to do that. So instead, we use a histogram, which isn't really the right tool for measuring mailbox depth, but we do it anyway. Histograms are great for measuring distributions. A good example of that is latency. We use histograms for measuring actor message processing latency. You can also use it for measuring things like response size. So how big is your HTTP output response or your HTTP input? Or maybe you might also use this to go ahead and keep track of a distribution of error codes, might be another example. So histograms are really useful, and they are a great way to go ahead and measure how values are distributed over an arbitrary range. So here's the data that is automatically produced by Phobos using OpenTelemetry. We keep track of actor starts and restarts. We go ahead and we trace when an actor spawns, and we can also correlate, let's say, the message that caused the actor to spawn in the first place. So if a parent actor receives a message and we create a child in order to process it, you'll see that. We also keep track of what an actor does during its pre-start routine. This is particularly useful for measuring things like Akka.persistence recovery, if you want. And then finally, we also keep track of crashes. If an actor throws an exception and crashes, you'll be able to see what the actor was doing when it threw that exception, and you'll be able to follow the whole chain of the actor's restart in a platform like Jaeger as well. And then we measure these same types of events. We measure how many actors by each type were started, how many were stopped, how many were crashed, and which exception types caused the crash. One thing we do really well on Phobos is we use low cardinality values for all of our metrics, all of our metric dimensions, meaning that we go ahead and we record, let's say, actor and message types, because there's only so many of them that can exist inside an application. We don't record metrics, and we don't using, let's say, the actor's path in order to do that, because you might conceivably have millions of actors per process. And that would result in what's called a combinatorial explosion if you did that. So that would reduce your throughput inside your system quite a bit, and it would increase your APM cost substantially. You would probably get a very large bill from a platform like Datadog if you were keeping track of that. And we'll address that, by the way, in the best practices section. Message processing. So whenever you do an iActorref.tell or an iActorref.ask, we capture the current active span and automatically propagate it to the actor who's going to process it. And we go ahead and we record this in here via this akka.message.receive operation. This is the new span that we create automatically when an actor processes a message. We're experimenting with the ability to turn that off right now. Next is we have these meters. We count the messages by message type and actor type. We measure the processing latency, and we measure the length of the actor mailbox queues. We get you a lot of data on how actors are processing their messages at runtime. That's one of the things that we guarantee. Finally, we have some clustering and log metrics and traces that we record. So we record in the akka.cluster the total number of nodes by role, membership status, and reachable/unreachable status as well. One thing I am looking at adding in the not too distant future is also being able to expose cluster sharding data as metrics, being able to go ahead and see how many different shard regions there are, how many different entities per node there are, that type of thing. So that's something that we're looking at exposing in the near future as well. And then finally, we also go ahead and trace data from the logging system. We trace all of the, let's say, any logs are automatically appended to the current active span when it's available. And then we keep track in the metric system of logs by level and exceptions by type. Now, other things that I don't mention specifically on these slides, Phobos can also measure things like the Akka persistence journal, how long it took an actor to recover its state. We'll go ahead and record that. We'll also be able to go ahead and record things like how many actors, if you're using distributed pub sub, received a message you published of this type. Phobos is pretty flexible in terms of what it's able to measure, and that's by design. It's meant to support a large number of different dynamic use cases. And so we've built a pretty robust system, and we've been testing it with 30 plus customers over the past couple of years. So we have a lot of data on what works well and what does not. And Phobos 2 is the sort of biggest improvement we've done on it in a couple of years. Now, next thing I'll move on to is how do you actually install and use Phobos 2? What's the process involved in doing that? Well, to actually go ahead and purchase Phobos, we have a platform that we launched in 2020 called SDK Bin. You can go ahead and buy Phobos directly through there. It costs $4,000 per year. We don't set any limits on the number of nodes you can install it into or the number of users who can access it. It's just a flat site license for your entire company and for all the projects in it. So what we do is we give you access to a private NuGet feed that's provisioned through SDK Bin. And then you can invite members of your team onto SDK Bin to access those NuGet credentials. That's basically how it works. So if you go into, let's say SDK Bin, you log in. This is me logged in under my account here. You can click on this access license keys section after you've bought Phobos, and this will go ahead and give you your credentials there. We're going to add the ability to generate multiple license keys for one subscription if you want to. That's something that we're going to add support for this year. But what you'll do once you have it is we'll give you a pre-authenticated feed URL that looks like this, where you have your API key and your organization name. I usually go ahead and I just add my SDK Bin credentials to my machine when I'm developing. .NET NuGet add source, I name it SDK Bin, add these credentials here, and then I'm good to go. If you are using NuGet.config, you can also go ahead and add this as an entry to that file as well. That would also work. I prefer not to do that just because I always worry about accidentally leaking our credentials since we do a lot of public open source work. So that's why we tend to do this quite a bit. That way it never gets committed into source control. Now, in terms of actually installing the packages, these are the kind of the big ones that you need. It's just Phobos.hosting is the only real Phobos package you need. This will bring in all of the others. And this gives you everything you need to go ahead and configure and install it. However, these packages up here are part of that OpenTelemetry processing pipeline we talked about. The OpenTelemetry.extensions.hosting package gives you the ability to tap into the iService collection that's exposed when you're building a generic host in .NET. And then we have some instrumentation libraries we want to use as well. One for ASP.NET, one for the HTTP client. And then finally, we have some exporters. So I'm going to use the Jaeger and Prometheus exporters here. Now, there isn't necessarily an exporter package available in .NET for every single APM platform. And that's because some of them use what's called the OpenTelemetry line protocol. Datadog, for instance, is one of those. In fact, I'll pull up my Datadog sample right here. And if I go to our CS project and I zoom in just a little bit, let's see. Well, I actually don't remember how to do that in Writer, but if you go ahead and take a look here, you'll see that I've added the OpenTelemetry.exporter.OpenTelemetry protocol package here. This is kind of a generic protocol for exporting metrics and traces, and lots of different vendors choose to use this instead of writing their own client, basically, for OpenTelemetry. So Elastic and Datadog, and I think Dynatrace all use this. There might be some other platforms that do as well that I'm not familiar with. But just because you don't see an exporter for your specific platform doesn't mean it's not supported. They might have chosen to have gone down the line protocol route. And the reason why is that way they don't have to write a client for every single language. They can just go ahead and target that protocol and handle it server side that way. So that's that's one thing you might notice when you go searching for the appropriate protocols. This is Datadog that uses this, for instance. Now to configure it, all we have to do is use these little builder interfaces right here. So on the left, we have our service collection that we're building up, and the OpenTelemetry.hosting package exposes these extension methods here, add OpenTelemetry tracing. And so we'll go ahead and configure our pipeline for configuring OTel tracing right here. So we add a resource builder. I'll talk about what that is in just a second. This is an extension method provided by Phobos that basically causes us to subscribe to Phobos's activities. Then we have a similar ones to the HTTP client, ASP.NET Core, excuse me. And then finally, we have the add Jaeger exporter. And if our Jaeger exporter was running on anything other than the default address, we could configure right here which IP address and port to use for Jaeger if we wanted to. And then for OpenTelemetry metrics, I'm going to do the same thing, except at the very end, I'm going to add my Prometheus exporter, since Jaeger doesn't support metrics and Prometheus doesn't support tracing. So I'm going to go ahead and do that. And this will have both of my OTel pipelines essentially configured. Now, the last thing I need to do in order to configure my app is I need to actually make sure that the Phobos actor cell instrumentation gets injected into my actors. And that's what this line, if I grab my highlighter, actually, I'll grab my pen. That's what this line does right here, is that gives me the ability to go ahead and inject my Phobos instrumentation into my application. So I say builder.with Phobos, and we'll go ahead and inject the Phobos actor reference provider into our Akka.NET actor system right there. Now, if you're not using Akka.hosting, don't worry. You can configure all this without it. We're just using Akka.hosting because it simplifies the entire configuration experience of not just Phobos, but Akka.NET itself pretty significantly. So that's why we're leading with that in our examples here. Now, I'm going to go ahead and do a little live demo where I'm going to instrument Phobos inside one of my applications. So let me pull up my app here. And let me pull up my, code sample. Here we go. So the sample that we're using today is from this Akka.NET code samples repository. I recently deleted everything out of this repo, and we've been adding new samples to it. We've got 2 in here so far. And the first one we're going to add Phobos to is this Akka.NET cluster sharding with Akka.persistence.SQL Server and Razor Pages. And I believe I already have this sample up and running. Yeah, here we go, on this tab over here. So the way this sample works is I have 2 different services. I have, if I go to my source code, I have a web app that is going to use, if I take a look at program.cs, we're using Razor Pages. We're going to go ahead and use Akka.cluster sharding right here. We're going to go ahead and basically use the Akka.hosting. I'm going to enable Akka.remote. I'm going to enable my own custom serialization. I'm going to enable clustering. And I'm going to add a shard region proxy. And I'm also going to go ahead and add a cluster singleton proxy as well down here. So I'm just going to use this with actors method to register that. And then on the other end, I have my host, which is going to go ahead and run my shard region. And it's going to go ahead and run my product index actor as an Akka.cluster singleton. So essentially, I have one process that is storing all my data. another process that's rendering my UI. And these two interact with each other using Aqueduct cluster shard region proxies and cluster singleton proxies as well. So if I hit reload here, this is going to go and query using Aqueduct persistence query all of the different products I've saved using the new product interface here. So I've been naming Buffalo Trace bourbon products here. So I'll go ahead and do another one. We'll go ahead and do Eagle Rare 10 and price this at $25 a bottle. And we'll go ahead and say there's 15,000 of those. We'll submit that. Great, that's all in here. And I can see Eagle Rare now appears on my list. And maybe I'll go and add one more. I'll do the Eagle Rare 17 here, which I've never been able to find in stores, but that's subject for a different day. I think that is $75 a bottle. And we'll say there's 100 of those. So all these different, let's say, entity actors here represent these are all individual sharded entity actors. So I'm going to go ahead and order 100 bottles of Eagle Rare. And maybe I'll go ahead and resupply 25 of those. And it looks like I don't show resupplies on here. I only show recent orders. So I'm going to go ahead and do another 2,000 bottle order. And you can go ahead and see all that appearing here. This, like I said, this is a pretty simple sample. But we're using ASP.NET Core, Aqueduct persistence query, and we're also using two different services here. So let's see how difficult this would be to configure with Phobos. Okay. So the first thing I'm going to go ahead and do, I think I've shut both processes down. Yes, I have. So the first thing I'm going to go ahead and do is I'm going to go to my SQL sharding.shared library and click Manage NuGet Packages. And you can see down here that Ryder is pointing out that I have some SDK bin packages available. So this is actually querying SDK bin. I've got phobos.hosting right here. And I'll go ahead and install it into my shared library that both the host and the web app are using. So install both of those. And I guess that should be done. Let me go ahead and build that real quick. Looks like I'm getting a NuGet package downgrade warning, probably because I'm running an older version of Akka cluster hosting. Yes, that's why. All right, so let me go ahead and try that one more time. Try running that. Yep, there we go. Okay, there we go. So Phobos hosting is installed now. So I just had to delete that older version of Akka hosting in there. And then I'm going to steal my OpenTelemetry configuration from, let's see. I'll go ahead and do that from here. So I'll go ahead and steal all of these. Paste that into this project as well. And then let's see, I think I need to go into directory.props real quick. Do I have one for this app? I guess not. Yeah, here we go. I guess I got to update it in here. All right, that's no problem. This is basically where I synchronize NuGet versions from multiple packages. Let me go ahead and grab that data from this project. Great, here we go. That goes in here. I believe these are all OpenTelemetry 2.0 and RC3. All right. So I should have everything referenced now. Let me go and compile, just make sure that's the case. Unable to find exporter.prometheus. That's why I did that. Okay. We'll leave it at that then. Time being. Nearest version 1.3 beta 1. Well, why don't I go ahead and do this? Get rid of that. Actually, try rebuilding it one more time. All right, looks like that worked that time. Great. I just had to downgrade that package. They're not all totally synced up, some of these. All right, perfect. That's all working well. Now, next thing I need to go ahead and do, in fact, I'll go ahead and create down here a new directory. This is one of the things that Akka.hosting makes really convenient, is I can go ahead and add some convenience methods for this. I'm going to go ahead and do SQL sharding, OTel extensions. We'll go ahead and do a public static class. Go ahead and do public iService collection. Add OTel. Like this. And I'm going to go and steal from my large network tests. I'm going to go ahead and add all of this. Yeah, perfect. Looks like I've already done this before. And this should just be called services. Go ahead and add all that. And I can get rid of that. And I can go ahead and add this. And let me go ahead and re-enable tracing while I'm at it. And this I don't need. And that I don't need either. There we go. And then I think the last thing I need to do is call add Phobos instrumentation. All right. So that should be all I need to go ahead and get everything configured. And we're primarily going to demo tracing here. The metrics piece I might demo in a moment, although we're running a little short on time. And let's see, this needs to be static. All right, that looks pretty good. So the resource, by the way, that we're creating is what's used in the tracing system to define the name of your service, the instance of your service, and optionally the version of your service too. So you'll see this show up inside Jaeger in just a moment. And you'll think, oh, okay, that's why we have, data about which version of SQL sharding we're using. Is because the add OTel. We've added OTel to there. And then in our web app, we'll do the same thing. I'll go ahead and add OTel. Builder.services, add OTel. It's got the capital. I think one other thing I need to do is I think I have to add for Prometheus, add use Prometheus, OpenTelemetry Prometheus scraping endpoint. This exposes /metrics endpoint for Prometheus. I do that there. Looks like we probably won't get metrics out of this process since I need to expose ASP.NET in there. That's okay. And then finally, I'll go ahead and do right up here with Phobos. And we'll go ahead and do Akka run mode.cluster. Go ahead and copy that. There we go. And I'll enable Phobos for this process too. Yep. All right, perfect. Now let me go ahead and compile all of this. And let's make sure it starts. I'll start up my host first, since that's our seed node for starting our cluster. So I'll boot all of that up. All right, looking good so far. I can see all my actors have recovered their state by the looks of it. That's pretty convenient. And then I'll go ahead and start my web application. Yep, it's fine. Okay. And looks like we're back up and running, so no errors of any kind. Let's take a look at Jaeger. So under Jaeger, you can see the SQL sharding host and the SQL sharding web app both appear as services now. That's what that resource builder is designed to help us do. So let's take a look at our web app. And we see here that we're receiving some timer messages. We'll filter that out in a moment. I know how to do that. But here we can see an HTTP request that arrived via ASP.NET. So I can see, if I take a look here, that we received an HTTP request from this user agent. This would have been me loading up the page, and that this data came from the OpenTelemetry.ASP.NET Core library. And this is all running on the SQL sharding.web app. And I can see that we did an ask operation to the shard region proxy, where we're basically going to expect a fetch all products response. This turns into a fetch all products query we sent to this shard region, this shard region proxy actor, or the cluster singleton actor. There we go, cluster singleton proxy. And then that message eventually gets routed to a different service, the SQL sharding.host. We can see that highlighted here. And I can see that the product index actor received it from this temporary actor here. And I can see that this message took us a total of 742 microseconds to process. So just, it's about 75% of 1 millisecond. And so end to end, this whole query took 7 milliseconds to process. So that's pretty fast. That's looking good so far. Now, if we want to go and take a look at something maybe a little bit more interesting, let's try taking a look at creating a new product. Or maybe let's go ahead and query an individual product like this one. Order, go ahead and do 100. All right, so we're going to have no more available units. We are totally out of George T. Stagg. If I go ahead and do find traces, I can see here that I have a route, product/product ID. If I click into this, we'll go ahead and see that this was a get originally. And we can see that we fetched this product. And eventually this query made it. Let's see if I take a look at all the actors here. That this message arrived on my SQL sharding host and here's my instance ID right here. If I had multiple versions of this process all running, the instance IDs would be different. And that's because this is determined by the host name of the process. That's how I programmed it. And so this arrived at, the sharding/products. This routed it to one of the shards it's hosting, which in turn routed it to this specific product actor. So you can see the messages kind of making these jumps all around the cluster here. And again, this operation took about 6.46 milliseconds. If I go back, and if I take a look at product/product ID again, you can see down here a much larger number of operations. This is probably my HTTP post, this whole thing. Yes, it is. So I can see this is my post that I did via Razor Pages. I can see the exact URL it came in on. And I can see that this message eventually made its way. It took, let's see, 50 milliseconds to get routed here. So it looks like this was this message being sent over the wire. So it looks like it actually kind of took the sharding system a decent amount of time to process this message, like 50 milliseconds. That's interesting. Tells me maybe I've got something I need to look at in there. And I can see down here that all these other messages didn't take very long to process at all, except for this one, akka.persistence.write messages. Okay, well, that figures. We had to do a round trip to the database there. And that's what this took. And so then eventually we get our write messages successful. And we go ahead and we send our final reply for all these different events back up to the caller up here and end this ask operation. So that in a nutshell is how you go about installing Phobos into an application. It's pretty straightforward. Now, the last thing we'll touch on is some best practices for using it. What you've seen me using so far in this demo is akka.hosting. Akka.hosting is a new thing we've been developing as part of Akka.NET 1.5. It's got a stable API. It's backwards compatible for Akka.NET 1.4, and it allows us to essentially build our applications using no HOCON. It still supports loading HOCON from legacy apps if you already have one, so there's no problem there. And this all integrates with Microsoft.extensions.configuration really well. Good example. If I go back to my sharding SQL Server app and I go to my host, we are loading our connection string for Akka persistence from Microsoft.extensions.configuration. This is something that required you to manually cobble stuff together before. Now it just works. So it's much cleaner than what we were doing previously. Manages Akka.NET's lifecycle with best practices. So when the Akka.NET actor system dies, we guarantee that the process also gets terminated, so you can't have zombies running around. And generally speaking, we are pretty good about asynchronously starting up resources inside here. The last thing that Akka hosting also has is the actor registry, which is that it gives us the ability to very easily pass around actor references to things like ASP.NET or gRPC or Kafka if we want. The actor registry is a service that's registered to your service provider, and you can just resolve it and then use a strongly typed key to access an actor inside of there. So this is something that's documented. We have a whole separate video on Akka hosting if you're curious about that. And it makes the development of internal middleware pretty trivial. If I want to develop a custom function for configuring telemetry in my app, like you just saw me do, I can do that pretty easily via a custom extension method. And Akka hosting renders Phobos a one-line install, meaning like it just takes a single line of config to do it. The next best practice is something that I should do for this sample, which is using what's called an iTrace filter. So an iTrace filter is like a little strategy pattern object. And this is designed to make it so you can filter out unwanted messages you don't want included inside your app. So for instance, if I go to my SQL sharding app, and I'm going to go ahead and shut down all these processes. I'm going to go into here and create a public app public class. iTrace filter. And I'm going to go ahead and implement this interface. I'm going to do if message is SQL sharding protocol member. What this is going to do is say only trace messages, only start new traces for Akka.NET messages if this is if the message implements this interface. Otherwise, if this message was kicked off as a result of something else we're already tracing, then keep it in a trace. And watch what happens when I go and include this inside my app here. If I go down to my with Phobos line, I go and do new app trace filter. And if I go to my web app, if I do, where is it? Here we go. App trace filter like this. And I go ahead and launch my host. All right, firing that up. And let me try my web app. Okay, there we go. Got everything up and running. Great. You'll notice before I had a ton of those timer message queries showing up inside my web app. What happens now, if I go ahead and do find traces, you'll see that none of those timer messages are showing up anymore. And the reason why that is because we're filtering them out. You can see some old messages from a couple minutes ago when I last wound down the sample. But going forward, there should only be new messages that stem from activities that I create. So, I just looked up eagle rare here. If I go ahead and do find traces, the next operation you can see is just that. None of the other messages that are being generated by things like timers or Akka.cluster events behind the scenes are going to be recorded anymore. And the reason why is because I'm explicitly filtering them out. This will help significantly reduce, if I go back to my slide here, this will help significantly reduce the amount of noise produced by Phobos. So it'll make your traces easier to understand and interpret. It'll give you less data to sift through. It also greatly improves the performance impact of Phobos. And then finally, and most importantly, it's going to significantly reduce the amount of money you have to spend on processing and storing that trace data. You get billed usually per the megabyte by a lot of these APM vendors. Using a trace filter will significantly curtail how many of those megabytes you have to produce and store. So it's a very good practice to get in the habit of early. Along those same lines, if you don't want to use a trace filter, we also have some marker interfaces that are installed in Phobos.actor.common. Phobos.actor.common is actually distributed on NuGet itself rather than on SDK bin. So you can install this into your app without necessarily having Phobos baked into it. And these come with some marker interfaces that Phobos will always respect, regardless of what the trace filter says. So I never trace means that this message either is never traced or this actor never produces traces. It works for both scenarios. Ditto with I never monitor does the same thing, but for metrics. And then finally, there's I never instrumented, which disables both. So Phobos uses some internal actors for keeping track of things like the current cluster state. We mark those internal actors as never instrumented. That way we don't end up producing like unnecessary tracing information that a user would not find helpful. So those interfaces are quite useful, being able to curtail the amount of data that gets produced as well. I think trace filtering is usually the better way to go. But for scenarios where I absolutely know under no circumstances should this actor ever produce a trace, these are the nuclear option to make sure that that never occurs. Now, a couple of other useful practices. This kind of gets more into OpenTelemetry rather than Phobos, but it's still great to know. One thing I like to do is add custom attributes to my spans. These make traces searchable via these properties, and they generally don't contribute to billable events on your APM platform. So a good example for that is if I go here and I take a look at one of my Phobos queries, let's say the actor type, Akka.cluster sharding.d data shard. Well, I can go ahead and search for both of these two types in Jaeger. I'm going to search across, I guess I'll do the web app. Maybe I'll do the host. And I can go ahead and say Akka.actor.type equals this. And I can see all the operations that have at least one span that matches that criteria. That's pretty powerful stuff. Or I could do things like, if I want to take a look at my unhandled messages, I can see if I can find any unhandled messages that involve this actor. So far, it looks like I can't. Now I see one instance where I have an unhandled message right here. And I can look for this, OTel status code equals error. And it looks like this was a unhandled message with a persistent shard coordinator. That might actually be a bug in Akka.net. So if I look for this, let's say, go back to operations here, all error equals true, I can find all the operations on that node where I have an error. And it looks like there's none on the web app, none on this other application, just here on the host. So that's what tags are, that's what attributes are for. And you can see an example in my slide here of where we configure one. It's this line. Let me grab the pen. This line right here. I can go ahead and set an attribute of user ID and pass in, let's say, the user's identity that's available via the message this actor is processing. That would allow me to search for all the traces that correlate back to that user. Or maybe you might want to go ahead and search for a product ID, or maybe you have some other correlation ID that's really useful. That's what all those are for. Now, the corollary to attributes for metrics is what's called tags. If I take a look at, in fact, let me fire up something real quick. Go to my command line. I'm going to fire up my Kubernetes sample down here. Whoops, looks like I'm connected to an Azure cluster that I deleted. Let me fix that. Yeah, go back to Docker desktop. That's more like it. I'll go ahead and let all that run behind the scenes. Okay, great. I'll give that a minute or two, but basically tags are the ways you aggregate metrics together inside Akka.net or inside Phobos. Or sorry, third tries the charm, OpenTelemetry. So here I'm creating what's called a histogram, which is one of the metric types, and I'm naming it processing time, and the unit of work is going to be milliseconds. So down here, I go ahead and I compute the total number of milliseconds that it took to process a block of code. I can create what's called a tag list right here to record all the different dimensions of data by which I want this value aggregated. So one dimension might be the actor type, maybe the message type. In this case, the host name of the server I'm going to use. And so these are how your metrics will be aggregated, will be across these dimensions. So a tag list will support up to, I think, 8 different, a tag list will support up to 8 different dimensions with 0 allocations. Phobos by default, I believe, uses 4 dimensions when you're running with Akka.cluster. It only uses 2 when you're running without it. We always record metrics by the actor type and the message type. And For some events, we'll record the exception type that's raised. And then we'll also, when Akka.NET cluster is running, we'll record metrics by the Akka.NET address and the role type in the Akka.NET cluster role list. If a node has multiple cluster roles, we just pick the first one off the list for that. We're hoping that they'll eventually add that resource builder support for metrics, so we won't need to do that anymore. That'll save everybody a lot of time and trouble, but they haven't implemented it yet. One thing you want to be very careful about with metric tags is these are billable dimensions. The number of unique values and the number of tags themselves contribute to billable events typically because they represent units of aggregation that the APM vendor has to support. So if you use a super high cardinality field here, like actor path or user ID, you can end up generating a super big bill, like $25,000 a month at least. So you need to be very careful with that. That's why you want to prefer low cardinality tags where the unique values are not significant in number. So that's something you want to be a little careful about. Now, that's all I have as far as Phobos installation and configuration advice goes. However, just to reiterate here that Phobos costs the organization a flat $4,000 a year. This includes free support from our team. I just did a Phobos call literally right before this webinar. But we'll help you install, troubleshoot, and get some architectural support on how to use it. You can go ahead and use Phobos in as many projects as you want, as long as they all belong to your organization. And we offer a 30-day money-back guarantee if you're not happy with it. So if you're not able to get Phobos up and running, we'll give you a full refund after 30 days, up to 30 days. And you can buy it instantly online at phobos.petabridge.com. This will take you to the SDK bin page I had earlier. So thank you very much for your time today. I'd be happy to go ahead and take any questions anybody might have. Otherwise, please feel free to go ahead and contact us. There's a submission form here you can use if you have questions about Phobos or if you want us to do a demo for your company. We would be happy to do that. Okay, let's see. Now we'll go ahead and see if we have any questions. Okay, from Jose Silva on YouTube. Can you briefly talk about Phobos and how it works with Akka.NET? Thank you. Yeah, Phobos is a instrumentation library for being able to gather metrics and traces for Akka.NET using OpenTelemetry. And that's basically what this talk kind of explored, was how to actually use it and how it works. Let's see, any other questions from YouTube or from Zoom? Okay. When should we use Akka.NET or Orleans? What are the pros and cons of each one? Oh boy. Well, I'm going to be on the presenting on the on.NET podcast on Monday, and I'm probably going to get that question there. So I think basically philosophically, in terms of Akka.NET versus Orleans, Orleans is very much a Microsoft technology in that it ultimately tries to hide or abstract infrastructure concerns from you in order to let you focus on your business logic. And that's kind of a pretty, I say this as an ex-Microsoft employee, that's a pretty consistent theme throughout all of their frameworks for the most part. You know, Entity Framework does that for SQL Server. And there's definitely parts of ASP.NET like Razor Pages that try to abstract some of it from you. That's basically kind of the general philosophy there. Orleans is also very much a cloud-focused product. You can't run Orleans natively on a phone, for instance, like you can with Akka.NET. It doesn't scale down that way. So it's meant to be sort of a distributed system framework from day one that tries to abstract away a lot of the infrastructure details. You should use Orleans if those infrastructure details aren't important to you, if you don't want to have to know about them. Where that model tends to break down is usually around performance. Or in some cases, it breaks down when you need to actually have very fine-grained control over things like actor life cycles, and also where actors are grouped together inside your nodes when you want to take advantage of locality. You have to start basically learning how Orleans works and customizing it in order to do that. Whereas by default with Akka.NET, it just does all of it out of the box. Because the way Akka.NET works is it exposes a lot of very fine-grained controls for you to be able to decide how and when your application works. And it scales down very well, so you can use it in a very approachable local process. You don't have to go and spin up an Azure account to go ahead and work with it. You don't need a database to work with Akka.NET from day one. It's all very simple and self-contained. And it does work. We have customers that use it, does work on mobile and embedded devices, so it can run without the network if it needs to. That's how most people get started with Akka.net typically. But where you pay for Akka.net ultimately is its learning curve is going to be higher, probably, than Orleans. Although I've heard from people that Orleans is hard to learn too. So who knows? But I would say, generally speaking, Akka.net probably forces the end user to make a lot more conscious choices about how things should be done. And we do that in the name of trying to go ahead and give you what we call a downhill development experience, which is that we give you something out of the box that is very unopinionated and has lots of fast moving, it's basically a very small number of moving parts, but in exchange is extremely fast. You start trading away as part of the academic experience some of that speed in exchange for other things that might be more important in that context. A good example of that would be data safety or consistency, or maybe you have a fault tolerance requirement. And those are all things where you can kind of trade away some of Akka.net's performance in exchange for those things. Whereas with Orleans, you kind of have a zigzag approach where they give you something that is fairly simple. Like I believe Orleans is still primarily one-way messaging. And you might want to have to go ahead and opt into something that's more complex to get some of that. But then on top of that, Orleans also doesn't give you any out-of-the-box default way of being able to organize how actors are co-located together on the server. You have to go learn how to customize that later. So you kind of have to do things in both directions there, which is trading away performance in exchange for consistency, but also getting rid of some of the magic in exchange for more manual control. Whereas Akka.net's all very linear from that point of view. Yeah, that's my short answer on it. I think that obviously I'm biased. I've been working on Akka.net for nearly 10 years. So tough to go ahead and ignore that when I give an answer like that. But that's I think probably the sort of objective way of kind of reasoning about it is what's more important to you, having control, kind of understanding how things work, or being freed from all that and getting down to brass tacks on your business logic. That's kind of really what at the end of the day, it probably comes down mostly to preferences of the developer, probably. That's probably what it comes down to, and to a degree, performance. Okay, question from Adrian. As I remember in the Akka.net documentation, it should be noted the ask operation should be avoided. I understand it's because it breaks to the events-based concept. I'm just wondering why your presentation is highlighting these instead. Am I wrong with these thoughts? So there was a blog post that came out probably 6 years ago called Don't Ask, Tell. And that was because Akka.net developers abused the hell out of ask. The reason being is that, again, this is speaking of that Orleans question, even the Orleans people struggle with this to some extent, which is Akka.net is always asynchronous all the way through. Whenever you tell a message, that tell method exits as soon as the method is handed off to the actor's mailbox, not when that message is processed, or not even when the actor begins processing it. So .NET developers, when they first saw it, were confused. Like, how can you have something that's asynchronous that I can't await on? And that's just sort of how to put it, that's just a way of rigidly thinking about how code should work. Akka.net is asynchronous without giving you things to await on because there's not really much point in doing that. The whole purpose of ask is to basically have the ability to create an end-to-end request response where you go ahead and wait until that message is completely processed and responded to by whoever is going to process it ultimately. So ask is fine to use. The problem was that because developers were so used to everything must be awaitable if it's asynchronous, they replaced every single possible interaction that could be successfully modeled with tell with ask. And this creates a bunch of scenarios that drive up memory pressure, create a propensity for deadlocking with actors, and all sorts of useless stuff. So ask is still really useful in a lot of contexts. In particular, what it's really great at doing is being able to correlate a request from outside the actor system with one inside the actor system. That's why we're using ask quite a bit between our web API and our actors, because our web API is operating using a request response paradigm, and ask is the easiest way to implement that. And it's also a very convenient way of exposing that data from the inside to the outside. With another web technology like SignalR, for instance, I could probably use publish and subscribe, which can be done entirely using tells, and I wouldn't need ask for any of that. So really the issue here is just making sure you're not using ask like blindly because you assume that everything that's asynchronous has to be awaited. And that's what people were doing back in like 2015 before that article was written. So that's the reason why that post is out there. Ask does come with some overhead. It's about 1/10 as fast as tell. But for most users' applications, that's probably not going to make a huge difference. Whatever your actor's doing to process that message will very likely be more expensive than the ask operation itself. It's only when you're doing things like publishing notifications to millions of in-memory actors where you would start to see that overhead show up. Any other questions before we sign off here? Nope. Well, all right. Well, thank you very much for your time today. I apologize for going a little bit over. I hope you found this helpful. If you have any other Akadonic questions or any questions about Phobos, you can always contact me on Twitter. I'm Aaron on the web, or you can reach out to us in the Akadonic Gitter chat room, or you can always email us at Petabridge. Otherwise, thank you very much for your time today. Really appreciate it and hope to see you all again soon. Thank you very much.